find the coordinates of its centroid. So since this diagram has different shapes, as a circle, a square, and there's a triangle there, we can apply the formula x bar equals sum of x a over sum of a, and y bar, which is the y coordinate, is sum of ya over sum of a. And well, there's an I there, just meaning the sum of each individual areas. So let's start with the numbered directions. So starting with the 1 is the area of the triangle. So that's 1/2 base times height. So your base would be 200 times the height would be 100. And then for the second, number 2 right here, we have 1/2 base times height as well. And then for the third one, this is simply a square. So that gives us 100 square. And for the third one, since this is actually not included as part of the figure, we would have to subtract this. And the area of a circle is pi r squared. Adding all this together gives us 20580, and this is in millimeter square. So now we need to find the sum of x bar a. So sum of x bar a. Well, this is simply the product of the coordinates of each separate shape and its area. So the first one, well, we have the areas here, so we can just write this down. We write the same thing. This is the area of the first, number 1. Well, the centroid will be 2/3 of the length from the 0 here. So 2/3 of the total length. So this is 200. So that's for the first one. And the second one is the area times the centroid. So the x centroid will be 2/3 of the length as well. So that would be 2/3 of 100. And for the third one, we have the area again times the centroid. Well, the centroid for a square is just the middle. So the middle of this is 50. But then we need to add an additional 100 millimeters to get it from the origin. So that would be 150. And we also have this. Well, since this was a negative area, because we're subtracting that, should have negative. And then the distance from here to the center is just 100. That was given initially. Calculating that gives us 272,4880.2. So now in order to find the x coordinates, we simply divide the value by the area, and we got that to be 20580. So doing that, we have 132.4 millimeters. 132.4 millimeters. So this is for the x coordinates. So for the y coordinates, we have the similar steps. So let me copy this, bring it down for the y coordinate step. Okay, got this here. So for the y, we have sum of ya over sum of the area. So for the sum of ya, we have the area of the first one, which is 1/2 base times height. Multiplied by the y-coordinate of the centroid for the first triangle. So this will just be 1/3 from the x-axis. So this will be 1/3 of the length, which is 100 on this side. And then we have the second triangle, so that's 1/2 base times height times the centroid. Well, the centroid here will be 1/3 below the x-axis, so this will be negative 1/3 times 100. And the area of the third one, which is a square, so it's L squared, times the centroid, so the centroid will be half, so that would be negative 50. Negative 50, because it's below the x-axis. And we also have to subtract the area of the circle and multiply by its centroid. Well, its centroid lies exactly on the x-axis, so that's 0. This results to negative 333.33. So now again, to get the y coordinates, we have this value divided by the area. So that was 20580. And that results to negative 16.19 millimeters. This simply means it's below the x-axis. So the centroid would be around here, negative 16, so that's below, so around here on this line. And your x is 132, so the middle is about 100, so 132 could be estimated to be around here. So your centroid will lie around this shaded area.